Okay, so this video is going to be on types of linear modeling. So it's really just an introduction to this part of the content. So basically, linear modeling, in a sense, involves fitting lines to bivariate numerical data. And what we're doing, linear being, they're going to be straight lines, basically. Okay, so when we've worked out there's basically a linear relationship, we want to model it, because then by modeling it we can use that information to make predictions later on, and we can use a simple linear model. Okay, and old style was this equation. We use this in further maths, y equals a plus bx, and I'll go into that a little bit in a moment. Basically, linear regression, okay, is the process of fitting a straight line to bivariate numerical data. Okay, and we use something called the least squared methods. We don't use any other methods anymore, so we're just using least squared regression. This is the most common, one of the most common methods used to find a line of best fit. Okay, basically a line is placed. A line is placed on a scatter plot such that the square of the vertical distances, what we call residuals, that's going to be in a separate how we calculate residuals, what they actually look like in a sense in a separate video. So vertical distance of residuals of each of the data points from the line that is minimized. So we want to have those vertical distances minimized. Okay. Again, like I said before, that's our equation. Basically, we're using the CAS calculator. Okay. Now, before we go any further quickly, what we're talking about here is basically what it's trying to say. If you've got a whole lot of data points on your bivariate data graph, and basically when you put your line of best fit, what it's effectively trying to do is minimize the distance between the dot and the line for every dot. Okay, that's why it's much easier for a calculator to do that for you. Now, we can actually generate though, and I have seen exam questions on this, generate that equation from this information. Okay, it is possible. Okay, so that's where we've got X bar SX is the standard mean and standard deviation for the explanatory variable, Y bar and SY the mean and standard deviation for the response variable. We've got R, which is Pearson's product moment correlation coefficient, and we have these two equations now, which you're going to use here. All right. Now, I'd probably use this one. I'd put something like this into your summary book. Quite important, because you're going to have, this is the form you need. Okay. Now, the slope, we're going to generate the slope by looking at R. So we're basically going to have equals R times SY divided by SX. Now, you'd have to be given that. And I have seen questions where they will give you this information. Once you've generated B, you've worked out B, you put that into this equation where you've got Y hat minus, and then going to multiply the beta of the slope of this calculated times X hat. So it's like the mean of the Y minus Pearson's times the mean of the X, and that'll give me my A. And then I can go Y equals A plus, let's try for color, B X. And that's basically my linear regression line of best fit from a least squares, okay, approach. You have to be able to use your calculator. You have to be able to use this. So make sure you've got that in your summary book. That's a given. You do need it, just so you can remember it. Okay? Thank you. Bye.